Previously in the complete creation.
Get a load of this. There has now been a few incredible findings of oviraptor dinosaurs, but buried alive while brooding on the nest. Hello and welcome back. Thank you for joining me in the next part of this exhaustive series on the controversial creation evolution topic. In the last part, we focused mostly on fossil dinosaur egg nests, and discovered that when you look at the evidence, if anything, it presents multiple serious challenges to the deep time models and supports the model of a past global flood, exactly as recorded in the Bible. But let's move on to these actual ages assigned to the rock layers. Where did those ages come from anyway? Surely those ages were arrived at by scientific process. Actually, they were not. The long and short of it is that these ages were made up. And then, as you'll see, the science was force fit to allegedly verify these ages. So where did these ages come from in the first place? Well, it all started with the advent of index fossils. You recall that stratigraphic layers were found covering huge areas in multiple countries and continents. Those individual layers were identified by both their characteristics like rock type and their fossil content. The original geologists made an index of the fossils found in the individual layers so that the sedimentary layers could be identified and traced. Later on, with the advent of evolution, these index fossils were hijacked and used to construct this fictitious geologic column. Ages were then assigned to the hijacked index fossils. Ultimately, all these ages come from evolutionary presumption. The ages are ultimately assigned to the fossils within the rocks, and the ages of the fossils are ultimately assigned by the presumption of evolution, and this presumed fossil sequence, which we've already seen, is actually fiction. All other methods or techniques of deriving the age of the rock bow to these assigned ages. For example, if you have a layer of rock like lavas, which do not contain fossils, the age of the lava flow is based upon the ages of the fossils below and above the lava flows. So if you have fossiliferous layers below the lava flow that are assigned to, say, the Ordovician period, wait, why was that layer assigned to the Ordovician? Because of the fossils contained within the rocks and the presumed age of those fossils based on the evolutionary geologic and fossil column. There is no other reason for these assigned ages. Those ages were made up on the assumption that there's an evolutionary progression of life in the fossil record, which was made up on the assumption that evolution has occurred, which was made up on the assumption of millions of years, for which there is no evidence, and in fact, boatloads of evidence showing otherwise. As Ian Taylor points out in his phenomenal, exhaustive book on the history of the origin of the evolution myth, In the Minds of Men is now in its 6th edition. The ages were assigned to the fossils first, and then when the various dating methods were invented over the years, those dating methods were calibrated to those assigned ages. Now, as I previously showed, you can see how these ages changed over time. This was especially noticeable with the ages assigned to the dinosaurs because they were such noteworthy creatures and as such were routinely mentioned in popular science. Now, one might contend that these ages changed over the years as the sciences improved and became more accurate. But that is not at all what happened, nor is it even happening today. These ages became more or less set in stone, pun intended, around the 1940s to 50s. And as you're about to see, any scientific data that contradicts these ages is assumed to be incorrect and promptly tossed in the garbage. The historical and even present-day evidence for this is extensive and exhaustive. It is all under the guise of calibration. So if a method of dating a rock is invented, you have to calibrate that dating method using rocks of a known age. That's just part of the process. So they run the new dating method on rocks that they have declared are, say, 500 million years old. They might measure the ratio of the elements of uranium and lead, for example. They now take that ratio that they measured and compare it to other rocks of unknown age. If the numbers match the readings from the rocks 500 million years old, they then conclude that the age of the unknown rock is also 500 million years old. Notice there is no questioning of the age of the original rock used to calibrate the method. That age is presumed. So what is needed is a dating method which is independent of any calibration conducted using these literally made-up ages in order to test those made-up ages. Do we have any such dating methods? Oh yes, there's several. Optionally, we can run tests using the various dating methods on rocks for which we can independently age. For example, if we can determine the age of a rock from archaeology or history. But first, because almost all of these dating methods use radioactivity as their foundations, let's take a quick look at what radioactivity is and how it can be used in calculating the age of an object. Now, all matter, of course, is made up of various elements which are composed of individual atoms. The atom is composed of multiple smaller particles like electrons, protons, and neutrons. You've probably all seen the periodic table of the elements, which shows all of the known elements like hydrogen, oxygen, sodium, etc. Now, hydrogen, the smallest of the elements, only has one electron and one proton. It is unique in having no neutron. The next element is helium, which has 2 protons, 2 neutrons, 2 electrons. Now, memorize that atom. We're going to revisit it repeatedly. The elements, of course, get heavier and heavier as you work your way up the list. They have more parts, more electrons, more protons, more neutrons. All of these parts have both attracting and repelling forces that have to balance out. The really heavy elements tend to be out of balance in the forces where you have so many particles. And so the atom will throw off some of the particles until it balances out. These particles being thrown off are called radiation. Sometimes it's a neutron, called neutron radiation. Sometimes clumps of particles get thrown off, like in alpha radiation, which is 2 protons and 2 neutrons. Notice it has no electrons, but it is identical to the helium atom. This will be important in a later dating method. Now, because it has no electrons, but it does have protons, then it has a positive charge. It is ionized. It'll try and steal electrons from the environment and so it's called ionizing radiation. Now, when put in an atom smasher, neutrons have been discovered to disintegrate into smaller particles and packets of energy, like protons, electrons, or particles like antineutrinos. So sometimes a neutron in an out-of-balance atom will disintegrate into smaller particles and be emitted as beta radiation. Okay, so the atomic number is based on the number of protons in the nucleus. Carbon has 6 protons, for example. Its atomic weight is the combination of all of the particles together, but electrons are so small and light that often they are ignored in the atomic weight, which gets rounded out. So normal carbon is called carbon-12. There is a carbon atom, which pretty much everyone has heard of, called carbon-14. It's called carbon-14 because while it has 6 protons in its nucleus, it also has 2 extra neutrons. So these 2 forms of carbon are called isotopes. So a great many atoms, including hydrogen, can have many different isotopes. Carbon-12 is a stable isotope, whereas carbon-14 is unstable and thus radioactive. It wants to get rid of a neutron somehow, and it does this as beta radiation. It breaks down into a proton and emits an electron and an antineutrino. Now the atom has 7 protons, 7 neutrons, has radioactively turned into a nitrogen-14 atom. So this process of turning into a completely different element or isotope is called transmutation. That period of time, while you have an unstable atom wanting to radioactively emit particles, that time can be long or short. If the atom is only slightly unstable, only slightly out of balance, that period of time could be very long. The more unstable the arrangement of atomic particles, the shorter the period of time it'll stick around before radioactively breaking down. We can measure that period by experiments in the lab. This period of time is called the half-life. And here's how it works. Let's say we got a clump of 1,000 carbon-14 atoms. Carbon-14 has a relatively short half-life of 5,730 years. So in 30 years, half of the carbon-14 atoms will have radioactively transmutated into nitrogen-14. If we wait another half-life of 5,730 years, half of that remaining carbon-14 atoms will have transmutated into nitrogen-14. In another 30 years, half of those remaining carbon-14 atoms will have transmutated into nitrogen-14, and so on. So every half-life period sees half of the remaining isotope breaking down or transmutating, leaving behind only half of the original radioisotope. Now, some isotopes have a half-life of billions of years. Some isotopes have a half-life so short, it's measured in seconds divided down to the 24th decimal place. For a lot of radioactive isotopes, they transmutate into another element, which is also radioactive, and it transmutates into still another element. Take uranium-238, for example. Through an alpha emission, it decays into thorium-234, which through a beta emission turns into protactinium, which through a beta emission turns it back into uranium-234. Now, uranium is called the parent element, and thorium would be the daughter element. And so you can go through this entire chain of radioactive decays where unstable radioactive elements give birth to other unstable radioactive elements until finally they decay into lead-206, which is stable and not radioactive. By research conducted in the lab, we know how long it takes for each of these elements to transmutate into other elements. So now you have the basis for modern radio dating methods. If we sample a rock and measure the amount of uranium-238 and the amount of lead-206, or the amounts of any of these elements in between, we can make a ratio of the two elements. A young rock will have more uranium-238, but over time, more and more of it radioactively transmutates into lead-206. So an older rock will contain more lead-206 and less uranium-238. Thus, with this graph, we can estimate the age of the rock sample. Now, this is a wonderful theory, but it has so many fatal flaws that it's difficult to know where to begin. Let's start with the assumptions. The first assumption that nobody ever talks about is very subtle yet significant. The assumption of billions of years. The assumptions of deep time. Now, we've only scratched the surface of how we know there simply has not been billions of years here on Earth. The bottom line is if that assumption that there has been billions of years is incorrect, then the rest of this dating technique gets thrown out the window. But it gets better. There's also a major assumption of the starting point on this graph. Usually the amount of daughter element in the rock at its formation is assumed, and is usually assumed to be 0. There is 0 reason for that assumption. In fact, you advocates of deep time, answer me this question. How were the elements of the universe formed? The heavy elements in particular. Now, I already know the answer is we don't know, and that the only naturalistic theories are wild speculations that defy all scientific observations. But nevertheless, I'm going to be gracious and give you whatever theory just shot through your mind. Let's assume your theory is correct. I'll just pull one argument out of a hat. Nuclear fusion in deep in a star produced heavy elements like uranium-238. I'm going to give you that argument, no contest. How about that? If you want to propose a different process, that's fine. Whatever process you propose, will that process that produces uranium-238 also not produce lead-206? Of course it will. And in fact, it will probably produce more lead-206 than uranium, because it would theoretically be harder to produce uranium as it's a heavier element. So whatever process produced the elements that went into, that rock will also produce all of these intermediate elements as well, wouldn't it? The correct answer is yes, Ian, it would. So you have no valid starting assumptions. None. You have no idea what the original mixture of elements in the rock sample was. Therefore, you cannot measure how much radioactivity has gone on in the sample, and therefore you cannot ascertain an age of the rock. But it gets better. Some of the elements in the decay chains are gases, like radon. Many of you will have heard of radon gas, because if you live somewhere like here on the Canadian Shield, which is composed of granitic bedrock containing a whole mess of uranium, radon gas leaches through the rock, through the concrete walls of your basement, and voila, you have radioactive gas coming into your house. Now, wait a minute. If radon, one of the intermediate daughter elements in the decay chain, if radon can pass right through solid rock, then how do we know when radon gas has leached out of our rock sample or leached into it? The correct answer is we can't know. So intermediate isotopes can be both inserted or removed into the rock, not just as a gas, but some of those elements can be leached into and out of the rock by groundwater. In all cases, the foundational assumptions are completely invalid. You can take all the measurements you want. You cannot deduce the age of the rock using any such radio dating methods. Let's take a closer look at one of those radio dating methods. Potassium argon dating works like this. Radioactive potassium 40 transmutates into argon 40. And look at that half-life. That's going to become very important in just a second. Argon is a gas, but just as important, it's an inert gas. It doesn't chemically react with or bind to anything else. So the idea is that when a rock is molten lava, the argon gas bubbles out of the liquid. The potassium stays in the lava because it's a solid. The lava cools into a rock, and now any argon-40 radioactively produced inside the rock will be trapped in the now solid rock. So we assume that the graph really does start with argon at 0 when the rock cools and solidifies. And over time, the amount of potassium 40 will dwindle as it turns into argon 40. So the older the rock, the more argon 40 will be found. We come along, we measure the ratio of potassium to argon, and we can deduce the age of the rock. Easy peasy lemon squeezy. On May 18th, 1980, Mount St. Helens in Washington state erupted. By comparing this photo taken the day before the eruption with the post-eruption photo, we can see that that mountain blew off a pretty huge chunk of its top. Inside the new crater, a lava dome grew over the next couple of years. We now know the actual age of that lava dome because we watched it grow. 10 years later, Dr. Steve Austin from Institute for Creation Research, now headquartered in Dallas, Texas, collected samples of that lava dome and processed the rocks through the potassium argon dating method. 5 samples from the same lava dome, the same rock, returned ages of 350,000 to 2.8 million years old. Radio dates from rocks we know are 10 years old. So remembering how the system works, when the rock first forms, there is no argon. Over billions of years, argon collects in the rock. Lots of argon indicates a great age. And I think 350,000 years to 2.8 million years is great age. So obviously, there was a lot of argon in the very young lava rocks. And obviously, the assumptions that the graph started at 0 is just dead wrong. The original mixture of the rock started out over here somewhere. So now that you guys are experts in potassium argon dating, you can analyze for yourself the response of Dr. Kevin Henke from the No Answers in Genesis website. In attempting to refute Austin's research, he actually made numerous very revealing statements. See if you can spot the error of his ways. Considering that the half-life of potassium-40 is fairly long, 1,250 million years, the potassium-argon method cannot be used to date samples that are much younger than 6,000 years old. A few thousand years are not enough time for argon-40 to accumulate in a sample at high enough concentrations to be detected and quantified. Wait, Did he just admit that if the rocks being dated were only 6,000 years old, that the radio dating methods would give an erroneous, inflated age of millions of years? Yes. Yes, he did. Thank you for that concession. So, not only will the advocates of deep time and radio dating methods reject their own radio dating methods when it doesn't fit their theories, they even tacitly admit that if the rocks really are only a few thousand years old, as the young Earth creationists claim, that the radio dating methods will return false readings on the rocks of millions of years. Furthermore, I am bewildered as to why Dr. Hankey would write this. Notice that he was attempting to refute Austin by saying that the rocks were too young and that the amount of argon would be so small as to not even be detectable. I agree, but that's just the point. That is not at all what Austin found. What Austin found that was so shocking was the exact opposite of Hankey's claim. There was huge volumes of argon in the rock samples, giving a false age, literally millions of years on rocks that we know historically were actually only 10 years old. But it gets better. Sadly, I'm out of time for this part. Please join me again in the next part of this series so we can continue our journey through this complete creation.
Coming up in the next complete creation.
Age, seeing as how it's supposed to be the more reliable and accurate one, so we'll conclude the lava rocks are 2.6 billion years old. That sounds impressive until you find out that there's Indian pottery in the lava flows, so we know the lava flows are actually only 800 to 1,000 years old. Oops.
You can catch the entire series in a variety of ways. You can watch the show online at www.completecreation.org or www.genesisweek.com. You can also purchase the Complete Creation series in full high definition on Blu-ray or video on demand at completecreation.org. Or support the Miracle Channel with a monthly tax-deductible donation and access the entire Complete Creation series in high definition through Corco, Miracle Channel's video on demand service. We need your support to keep this program on the air. So please pray for us. And if you wish to financially support the program, Canadians can make a tax-deductible donation to Core Ottawa, Canada North Post Office Box 72075, Ottawa, Ontario, Canada, K2K2P4. Or you can make a donation via PayPal online at ianjuby.org/donations. And thank you for your support.